All right, hey everyone, how's it going? I don't think we have anyone online yet, but I wanted to go ahead and start talking. I'm gonna do something fun today. I've been wanting to do this for a while, so it's kind of fun. I'm a nerd. I love movie props. I love things that'll remind me of TV shows, movies, characters, all those fun kinds of things. Um, and I've had this VR set for a while, and I really enjoy making 3D printed add-ons for this. It's funny how well VR and 3D printing go together, because you can make so many things that will help you in your game. You can have virtual things turn into reality. If you think of it that way, like 3D printing, like little like pistol grips or something to hold while you're shooting in your VR game. There's so much you can do with 3D printing in VR. That being said, this is going to be a little off topic. I'm gonna print something different. But just a couple examples of what you can print for 3D printing. So this is, if you're not familiar with VR right now, this is the Oculus Quest, the first one. So this is basically, it was the first standalone headset you could get. Not a bad system. I enjoy it. I plug it into my PC. I can run it through my PC as well. Not a bad headset. I'm not a fan of the fact that you have to sign in with Facebook nowadays. Probably wouldn't buy it again if I knew that was the case. That being said, it's a good piece of equipment. But you can add some things to it. So I've added. You can see here on this camera some little pieces. This basically helps with wire routing. So if I'm playing while I have or while I'm charging it, I can route the wires from the side port here through this guy. I can route it through this guy. So that's pretty handy. Keeps the wires out of your face if you're trying to get to something in like a battery pack in your back pocket. So those are kind of nice. Pretty simple to make there. Hey, it is Cooper joining in with us today. Hey, Cooper. So I don't know if you heard, you might have missed it. We're making something for VR today, and we're using a whole bunch of new tools. It's going to be a good time. It's going to be hilarious. I think you're really going to like what I'm going to make for this. We're going to use a little bit of engineering too. So it'll be a good time. But right now I'm just explaining the kind of things that you can make, how 3D printing and VR interact so well together. So this is something else I 3D printed. So this is the controller, and I 3D printed basically a little handhold for this. So typically the controller is just the black part here. You hold on to it. You put the wrist strap on like you're playing a Wii, and it's fine. But it kind of takes away from the immersion. You're always having to hold on to something if in VR, even if you're not in the virtual world. So found this on Thingiverse. Pretty cool little file to print out. Basically makes it kind of like the Valve Index, where you don't always have to hold on to it. So if I'm here, I'm using my buttons, whatever, I can actually completely let go, and it will be, I don't know if you can see that there, it'll be basically stuck in my hand. So I can throw things a lot easier. It's not going to come off. Really like that. So other cool things that you can 3D print for VR. That being said, we're not doing anything useful today. Like I was saying, I love characters. I love movies, TV shows, and all that. So I thought the second I saw a VR headset, that shape looks really familiar to me. And if anyone has a guess of what it is, well, you win. But I wanna show you what I'm thinking here. Does anyone recognize that guy? Yeah. So basically, I thought it'd be really hilarious to turn this Oculus Quest into basically Bender's the robot from Futurama, turn it into his eyeballs. Terminator. Well, I don't know if I could put a red glowing eye on here for Terminator if you wanted to do that. But yeah, so I thought this would be really funny. It's a nice, simple project. Get to utilize some new software. Get to use 3D printing, a little bit of artistry, I guess if you could call it that. We're going to be drawing this, so it could be fun. So that being said, let me show you what we're going to use today. I'm going to put this on my other desk real quick. Let's get that out of the way. Oh, goodness. Maybe we'll make a Terminator mask sometime. All right. So, we're going to do Bender, and specifically just the eyeballs. So, as you can already tell, there's a little bit of a challenge. Most all cartoons, modern day or whatever, have them facing at a, say, I don't know what that is, a 45-degree angle. They're never looking straight on. So it makes it kind of tough because you don't really know what his eyes look like because he never really looks straight on. So we have to find these weird intercuts like that to kind of see, like, okay, what does he actually look like? So it'll be kind of a challenge to make this look like Bender in the real world. But I think we can do it. Just make some eyeballs, maybe he's always angry. I feel like this one is the best representation of the Bender I know. He's always angry, got some kind of mean face, some I guess you could call those eyebrows, some angry looking eyebrows on. So I was kind of thinking going that route, doing some angry eyes. Maybe, I don't know what's going on with poor Fry there. But yeah, you can see, so his eyes don't always touch the very, very bottom of the frame. I think we can pull that off since we don't have a frame, we just have a front surface. So I'm thinking maybe some nice semicircles with slanty eyeballs, kind of resembling this, kind of resembling that, but, the full circle. So I think we're going to go for something like that. So let me show you the tool we're going to use to do this. So surprisingly, this is new to me. So what you see here is Autodesk Fusion 360. So I have never used this program before in my life, but I've used a handful of others. I've used Autodesk stuff before. I really, really enjoy Autodesk Inventor. I've used that for, geez, almost 10 years. Absolutely love it. Super straightforward, very clean, very easy to follow user interface wise. Absolutely love Autodesk Inventor. Played around with SolidWorks, played around with Creo, Pro-E, CATIA, or CATIA, however you want to say it. So I played around with a lot of these programs, and they're basically all the same. Well, I say that, I don't know yet because I haven't used this one. But they're basically all the same. You start with a 2D sketch on a flat surface, so picture my cutting board I typically have up. You start with the sketch on that, and then typically you'll do what's called an extrusion and basically build up from that. So these are mainly additive processes. You can do some cutting away to kind of refine some shapes, but most of this is you sketch, add, sketch, add, sketch, add, or sketch, cut, sketch, cut. So we're going to try to do that with the Bender eyes. So, how do we start? Well, let's play around with it. So like I said, typically it looks like it's already wanting us to start a sketch. So basically what I've learned about Fusion Autodesk Inventor, it does quite a few different things for being a smaller program. It's for hobbyists. It's for collaborative design. It can also do some rendering and animation. So we don't really want to do rendering and animation today, just a design. So we'll keep it on design. Okay, and then it gives us a couple options up here, it looks like, for our the beginning of our design. So we know we're going to want a solid because we're going to make a 3-dimensional part. Also looks like we have some options for surfaces. We won't be using sheet metal, almost never use sheet metal stuff. And then some good looking tools. Looks like we can do some interference tools, maybe some FE tools. So this will be kind of cool. Section analysis, those come in handy, but we don't really care about any of this. So I think we're going to start with, oh, there's even a, can I even slice in this program? Really? Okay, that's pretty neat. Outputs to STL. So we will be using that. Okay, so keep that in mind because we'll have to come back for that. And we'll also be using Cura today. We'll get to set that up for the 3D print. So typically, I'm just going to start as if I was using the programs I know. We'll see if it works, but this is going to be a comprehensive tutorial on how to make stuff up and see where it takes you. So usually what I'll do is start with the sketch. It's what I always do. It'll ask you to pick a plane we want to sketch on. I always like the plane that it starts us out on, with Z being our perpendicular axis to our plane. So I'll pick this plane here. So when we pick it, it should align us to, yep, okay, so it'll align us to our X and Y axis. Looks like it's giving us a little palette here. That's pretty neat. Interesting. Can I dock this? I don't know. It looks like I want this to be up here. I'd love it to be up here, but I don't think it's going to give us that option. So we'll keep it out there, but these are some good things to have. Show profile, show points, show dimensions. Okay, so this is good. This is good. So I guess we'll kind of get going here. So I know y'all can't see. I need to learn how to screen capture. I can only do window capture. So I know you guys can't see what I'm looking at Bender wise. But I'm pulling up Bender's his face every now and then to reference. So it's basically a couple circles. Looks like he's got some. Well, looks like he's got some. I want to open image in new tab. It looks like he's got some squares as his pupils. Okay. Yeah, so this should be pretty easy. So let's just start with the circle. Now you're probably thinking, well, what size circle should we start with? So let's get some measurements from our Oculus here. Just so we know, so we'll do measurements basically up and down. See how big of a circle we can fit in there. We don't want it too huge. We also have to keep in mind some of our infrared sensors are here. We don't want to block those. So we'll probably keep it within here. It doesn't have to be perfect. Again, it's not going to be a Bender mask. This is just going to be some eyes that I'm slapping on the front of my guy here. Okay, so we will take. Oops. We'll come back to that here soon. So we will take our calipers. Okay, let's do everything in inches. I work in inches in my job. So I'm going to work in inches here. I'm sorry, all of you people who love SI units like I do. I was converted. I am no longer allowed to use SI units, so don't hate me. Okay. Yeah, sorry, there's a little bit of glare. I'm trying to make sure that I don't glare out. Okay, so let's just basically take, I know I have some half-inch cubes here, but we're going to do it the fun way. I bought this thing, we're going to use it. So let's see. Basically, using the entire thing I got here. Okay. So the total height of this guy, just take it somewhere in the middle. Total height of this guy is 3. I don't know if y'all can see that, 3.85 inches-ish. Okay, so we need it less than that, so if we just kind of guess, Again, this is kind of artist, kind of engineering. It's the best of both worlds. Doesn't have to be perfect, but it's going to be more perfect than if I was just to YOLO it, you know? So 2.75 inches looks pretty good. I think that's going to put us right about in the middle of here. It's going to leave us some room for our edges. So we're going to go with that. Let's do 2.75 inches. Oops, did I change my... somehow change that? Oh, apparently I zeroed it. Okay, 2.75. 2.75. So let's do that. So let's go back to our fusion guy here. Okay, and we're just going to start creating the objects that we need to have. This look right. So I'll take a circle. So basically how the circle works, we assign it a midpoint. So our midpoint is going to be the midpoint of our, basically our home coordinate system. So where everything is defined off of. And we're going to basically type in a radius now, 2.75. And sorry, we're using the old computer today, so everything's going to be a little bit slow. Okay, and there we go. So, ta-da, we've made a circle. Pretty simple. I actually, I really like the style of this Fusion 360. It's very, very clean. Okay, so now what we'll need to do, if we look at our Bender guy, again, I know you guys can't see it, but imagine Bender in your mind. He has a square pupil in the middle of his eyeball, and we're just going to call it middle. It looks pretty middle in every picture I've seen, unless he's emoting. You know, his eyes don't move, just his pupils. So I think we're going to put him right in the middle. Just for sake of, again, we're putting a cartoon in the real world, so it's going to make it kind of a challenge. So it looks like we have grid snapping here, so that's interesting. Now typically when I grab a rectangle, so these are basically our tools that we can use. We have tons of different tools here to draw. And typically when I grab a rectangle, I can make that rectangle into a square if I hold shift. So I'll give an example right here. So if this is my rectangle, I can do all kinds of stuff like that and then define a length and a width. That's cool, but I don't really want that. So get rid of that. But if I hold shift, I should be able to... oh, no, this one doesn't do it. Maybe they have it in alt. Nope. Do they have it control? Maybe they don't have it at all, and I'm just supposed to figure it out. Okay, well, they don't have a create square easily. That's fine. We can just define our side lengths. So what I want to do, though, when they have a rectangle, there's a couple different ways we can define a rectangle. So the one we just did was a 2-point rectangle, so we'll take 2 points and basically define a length and a width. To make it easier on ourselves, we're going to do a center point rectangle. So we're basically going to define this rectangle exactly how we defined our circle, just we're going to make a rectangle instead. So we'll select our center, and then we'll do a length and a width. I don't know the exact dimensions and I guess proportion of Bender's eyeballs, but we can eyeball this. Get it? Eyeball it. We can eyeball this. We can guess, and then we can adjust it later if we need to. But to me, right there looks pretty good. I don't know, 0.4 inches. Sure, looks good to me. We'll do that, and we'll hit escape so we don't make any more rectangles. So there we go. So now we have a rectangle inside of our circle. Pretty neat. Alright, and then the last thing we'll need to do is, like we said, Bender was angry. He's rarely ever a happy robot, so he has some slanty eyes to have him emote. So we'll probably just draw. It's interesting how they have this line defined, but we'll probably just draw a line. I don't know what makes him look angry. We can kind of guess. So how about there to there? Okay. Yeah, kind of looks angry to me. I'll go ahead and escape here. Now, on some of these programs, we will have the ability to do what's called a trim. And basically what that'll do is take extra lines we don't need and get rid of them. So it looks like we have that option here. This is one of my favorite tools in Autodesk Inventor. Yeah, so it looks like when we hover over some segments, so when we drew this line, we connected it to the edges of the circle. So you can kind of see when we hover over parts of the circle, they'll turn different colors. So wherever it turns red is what will disappear when I click it. So I want to get rid of this top part because that's what is making him angry. So we'll go ahead and click that, and it'll take that line out and also take that middle section of our eye out. So there we go. You can kind of see we have this angry looking eye. So that's a really, really nifty tool we got there. Alrighty, so I think that's all we need for now. So this is our first sketch. Congratulations! You have successfully made a 2D sketch in Autodesk Fusion 360. It's my first one, actually. So we're going to go ahead and click this Finish Sketch. Boop-a-doop. Alright, so now we've finished a sketch. So check it out. If we zoom out, and then, hold up. If we rotate this guy, you can see that we have this flat sketch on basically a plane. So there's no depth to this. I can't do anything with this yet because it's basically like I just drew on some paper. So what is the next step, you may ask? Well, I shall tell you. We need to make it thick. And to do that, we'll do what's called an extrusion. And it's this guy up here. So almost all, like I said, almost all 3D software does the same thing, except for don't use Creo. Never use Creo. Creo's the worst. I don't know why people use it. Don't use Creo. So I'm going to use this extrude, and now we'll have to pick what's called a profile. So anything that's enclosed by lines is a profile. So as long as everything is within some lines, we can select it. So it looks like, yep, this is about the same as I'm used to. So we'll click this profile, and that's basically the entire sketch we just did. So you can see it selects the area in between this outer black line and this inner black line. And basically that's going to allow us to create 3D-ness. So now you can see it's asking for another dimension. So what this dimension is how high up we want this to go. Basically how thick this piece is going to be. So for now, I'm going to do pretty thick. I'm going to do a 1/4 inch, and I'll tell y'all why here in a second. But we're going to go pretty thick. And we can see how thick that is now. We kind of go over here. Yep, so there you go. So you can see we made a 1/4 inch thick angry bender eye. I don't know about you guys. I really like the shape of that. That's pretty dang cool. It looks like a bender eye. I'm happy with that. I don't know. What are your thoughts, Cooper? my one guy who's watching the process. Okay, so we'll keep that. So that looks pretty good. And the good news is we only have to make one of these for now, because in the slicer that we'll use later on, we can actually just flip the entire thing, and we don't have to create. So this is the left eye, or I guess the right eye. And we won't have to create the other eye because we can just mirror it in the next program that we use. So that's cool. All right. So here comes the fun part. So why did I create this so thick? That's pretty thick. A 1/4 inch is a lot of material, especially when you're 3D printing. That's going to take a little while. So why did I make it that thick? Well, let me show you. Let me switch back to our workshop view. Okay, so let me show you why I did that. So if you look at the Oculus, the front of it, and it's kind of hard to see with the shadow there, the front of it is not straight across. It's actually a very slight arc. So I added that thickness because we now want to take a slice out of that so that we can put in this arc and that it will lay nice and flush all the way across, instead of having like a think of basically a pencil or something across here. It's going to come tangent to it. It's not going to lay flat on this. And I'm not a perfectionist, but I'm pretty close to being a perfectionist. And I want it to lay very flat. I want this to look very nice. As nice as it can be for Bender eyeballs. So we're going to put that arc in there. Now we do have to do some math. So bear with me here. I know not everyone's a fan of math, but we got to do something to make this work. So let me break out. Let me show you guys how we're going to do this. Move this guy here for a second. So how do I find basically a radius of a circle when we don't have the complete circle? Let me show you. Let me find my... where did I put those things? Sorry, I'm unprepared today, apparently. Yeah, I'll use some black. Alright. So how do we find it? So we have an arc. Say our Oculus looks kind of like that, right? Basically, it's probably a... I'm not a great drawer person. Looks kind of like that. So that's good. We know that, but how do we find any dimensions off of this? We don't know anything. We can assume that this guy... Wow, this is... I picked the worst marker. Hold on. We're going to start it. Do you work? No. None of my markers work? That one looks better. Let's try this again. You can't do math if you don't have good writing utensils. So here's our arc, right? That's the front of our Oculus. Now, we're assuming, and we might be wrong, but for the sake of this project, it's good enough. We're assuming, it's not a perfect circle, but it's a circle. We're assuming that this thing is a perfect circle, right? So if we were to continue the arc of the Oculus all the way around, basically make a big circle. So what we want to do, and this will bring you back to geometry class, is find... Oh, wow, I cannot draw straight today. Let's find this value. So this is your radius. You guys should remember that. Oh, everything is mirrored over there. Should I write mirrored for you guys? This is your radius. All right, I'm writing mirrored just for you, just so you know, because this camera is upside down. It's a whole thing. Okay. So we want to find this radius. We can make dimensions off of that in our Fusion 360. And that's how we're going to cut in the radius of this for our the back of our Bender eyes. So how do we find that? Well, let's start with the dimensions that we do know. We can easily take this distance, right? So this is, if you kind of think of it, this is kind of like the back of your Oculus here. You know, you put your eyeballs somewhere around here. So we know that distance. That looks like an Oculus, right? Yeah, kind of looks like an Oculus. So that's so we can measure that basically with the ruler or the calipers. I'll break the calipers back out. So we can measure that. What else can we measure? Well, we can also measure this distance here. We're going to go ahead and call that, I'll call it X, because that's, you know, I can mirror X pretty easily. So we'll call that X. So we know these two dimensions, and we'll call this, I don't know. How about L? Does that work? So X and L. Good enough for me. All right, let's call it Y. I like Y better. There we go. Yeah, it's still backwards for you guys. All right. I wonder, can I flip that so it's not mirrored? Bear with me, because that'd be really nice. I have it flipped one way, but can I mirror it? Flip it vertically. Yeah, we can work on this later. It's no big deal. Here we go. All right. Now we're talking. Yay! Okay, nice. So now I don't have to... Okay, that's better. So now I don't have to mirror everything for you guys, and it's still upside down. Perfect. So we're R, call it X, call this Y. Good, good to go. We figured out the technology today. That's what counts. Okay, so these are all the dimensions that we can get, minus R. We don't have R, that's what we want. So how do we do this? Well, there's a couple things that we can assume. Since this is a circle, the radius is going to be the same everywhere on the circle. That's what circles do. Which means that the radius here is going to be the radius anywhere on the circle, which also happens to be here. That's a nice thing to know. Now we have everybody's favorite shape to work with, a triangle. Oh, you see where I'm going at? Probably not. So this is a right triangle. This is super, super nice. Because this is just a distance up and down, and then we're taking the perpendicular measurement there. So that's a right triangle, which means that this is a right triangle. Right? Remembering geometry. So what does that mean? So we can use that theorem, everyone's favorite theorem. And we can say that, and remember, so this is no longer R on this leg. This is R minus an X, right? So we can say that R minus X is this length squared plus Y squared equals, and this is also our R, right? Here, let's do this. We'll call it this so we can keep it clean, equals R squared. Cool! That's easy to solve, right? So let's go ahead and solve this. So we already know, so we need to FOIL that, if you guys remember that. So that's going to be something like R squared minus 2 R X plus X squared. That sounds about right. Then add our Y squared. That equals our R squared. Cool. Now we just have to solve for our R, because that's what we want to solve for. So R squared minus R squared, that just equals 0. Negative 2RX plus X squared plus Y squared. No, this is a thick marker, it's a little hard to see. Okay, and then we'll just solve again. So X squared plus Y squared equals 2RX. And then one more time, X squared plus Y squared over 2x equals R. So there we go. So a little bit of math, and we can basically figure out with two dimensions, what our radius of the circle is going to be. So that's pretty nice. I just want to make sure, did I do that right? I always like second guess myself, right? So r squared x yeah, did it right. If I did it wrong, someone will catch me, right? Call me out. I know what's up. All right. So that's cool. So let's get some measurements for this thing. Enough math. I don't want math. So this might be too big for our, I'm looking at the Oculus again. This might be too big for our dollar calipers in this dimension. So I'll go ahead and just use, I have a scale down here on my cutting board. I'm just going to go ahead and look at this. So if we're measuring from here to, it's not perfect, it'll work. So it's like just under 7 inches. We're going to say, it's actually pretty close to 6.5. Might call it, we'll do 6.75. Sound good to you guys? So we'll say our, and that's the whole thing. So this is the whole distance. So our y, you can see that, y, 6.75 over 2. All right. And then whatever that is. And then we'll have to measure our distance inward. So that's going to be kind of tough because it's a little small, but no big deal. So you can see I measured on these seams right here. So you can see there's the seam kind of going around. So we're going to measure that. So basically just going to take from the front to where that, about that seam lines up. Again, will it be perfect? No. Will it be good enough? You bet your socks. Is that even a saying? So that looks pretty good to me. It's probably a little off. That's fine. So we'll round it down and say 0.64 inches. Sounds about right. I'm only 0.64 inches. So this is around 6.5. Say 6.5 because that's a nice round number. X 0.65 inches. So now we'll use our little formula here. Just realized my calculator died. Sad life of an engineer when your calculator dies. Okay, so 6.75 divided by 2, and that is our y. So we want to, we're going to square that guy plus, wasn't a square root, right? Okay, plus 0.65 squared. That doesn't seem right. Oh, yeah. That's right. Okay. Equals. I really wish I had my good calculator because I hate these computer ones. They're the absolute worst. They make no sense. You have to click buttons. I want to type on my keypad. So, okay, so blah, 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 over. So we're going to divide this whole thing. And then, see, it's terrible, man. I can do parentheses. 2 times 0.65. Get my MATLAB up in Hizzle. Okay, so we're dividing that number by 2 times this number. So that means our radius is 9.08 inches. Okay, so let's kind of think through that. So this is our Oculus, and we have a ruler here, and we're saying the radius of this circle is about 9 inches. So we'll line up our 9 there and kind of sweep it around. Okay, yeah, I mean I can kind of see that. What about you guys? I think that I think that sounds reasonable. Oh, we'll call it that. Cool. We did math. We figured stuff out. We're going to say 9.1 inches. I bet you some guy from Oculus will see this and be like, oh, he's discovering our secrets. Yeah, take that, Facebook. I hate you. Okay, I'm just kidding. I love you, Facebook. I don't. Okay, 9.1 inches. So now let's bring that. We're going to go back to our Fusion. I'm going to keep playing with my marker. Go back to our Fusion. And we are going to cut that radius into our bender eye. Okay, now to do that, we have to create another sketch. The issue with that is all of a sudden, we don't have any, well, we do have a flat surface, but we want this to line up with the, what axis would that be? With the y-axis, because we want this to be straight up and down for the bender eye. So what we'll have to do is create a place to do this sketch on. And typically, I am able to create a plane. Oh, we can see this has all the good stuff in it. So we want to make a plane, and we can sketch on planes. So we're going to make a plane tangent to the circle that we made for Bender's eyeball, but going through the basically the y-axis. So let's do our tangent plane. So we're going to select the surface we want it tangent to, which will be the cylindrical face. And we want the, oh, look at that. I think it already has it. It already has it at 0 degrees. Reference plane, so we're going to reference, I guess it will be our x-plane. So let's go ahead and I'll step y'all through exactly how we do this. So we want to reference our x-plane, and we want it to be parallel to our x-plane. So we'll go to our origin, and we have our origin point, our origin axes, and our origin planes. So we're going to do the XZ plane is what we want it to be parallel to, because X is our red, Z is our up. So we want to do like that. Whoop, whoop, whoop. And I don't know what it's doing. Maybe I shouldn't have done that and just let it do its own thing. 1 errors. Okay. So maybe this is a little different than what I'm used to. Well, let's try again. I liked the way that it had already had it set up. That looks really nice. So basically, that's what we want to do. You can see here if we rotate it, it'll go back and forth. So we want it 0 degrees. Okay, so we'll slap an OK on that sucker. We can have, as you see, our plane that we can draw on now. So we'll go ahead and select our sketch again, go to our new plane that we just made, and now we're sketching basically all all over our surface here. Okay, so remember we did a 1/4 inch, which is good, but we want to leave some room so that we do have material to print. So typically what I'll do is about 1/8 of an inch. It seems like a pretty solid thickness. The printer likes it, doesn't take too long, so we'll leave 1/8 of an inch there. So keep that number in mind. We'll come back to that. But now we want to create our circle. So we can do that in a couple ways. You can either do just a basically an arc here, which we'll probably do. I'll probably do it that way instead of doing the whole circle. And you'll see why I will do that. But first, so this is where I need to learn some things. I want to make sure I can reference this geometry when we build on it. To do that, there's usually something called project geometry, and it'll basically take the outline of the geometry below the plane we're sketching on and put it on our plane so we can use it later. I don't know if Fusion 360 has it. I'm looking at it right now. It doesn't look like we're going to be able to use that feature here. That's a little upsetting. It's a really nice feature. Hopefully it'll do it automatically then, so we don't have to actually tell it to project. It looks like I can kind of select some of these edges, which is nice. So maybe we don't have to do anything like that. So we're going to select an arc. We're going to do a center point arc. So basically, oh, we want to select the center point. We don't want to do that. So we're going to do a 3-point arc. I apologize. So what this will do, it will select the two ends of our arc. So we'll say we want this to be, see, that's what I was worried about. It's not going to let us select our previous geometry. So we need to figure out how to do that. Let me get out of this arc stuff. Whoopsies. Sorry, I work with 8 different programs a day and they all have a different control scheme. Okay, so maybe if we, well, that's not what I want to do. What did that just do? Okay, so I want to project this. How do I project this face? Fill the shame first. So we don't want any of that. Can we create from project and include? There we go. It's just hidden way down in here. So we want to project things. So watch this. So if we click this project, we'll go over to our bender eye that we've already made. We can either select just the outer lines of it or select the whole thing. We'll select the whole thing. That's fine. And we'll say OK, selection filter, that's fine. I don't know what all of this is, but we're going to click OK. And boom, there we go. So look, so now we have some corners that we can reference. We have the upper and lower surfaces we can reference. We even have some of those other lines that we created when we made the slanty eyeball that we can reference. We probably won't reference that, but it gives us the option, so that's pretty cool. So we'll do our arc, go back to our 3-point arc, and now look, we can select that guy, bam! And then we can select this guy, bam! Okay, and now you see we have this big old arcy thing. For this, we want to use the number that we just came up with. So let's make sure it's aligned on our center axis here. We'll do that. I don't know if it'll let us define it. Okay, it won't. That's fine. So let me show you what we do now. So we defined this arc, and it is constrained to the 2 corners. So basically, there's some color schemes to keep in mind. So on this one, it looks like if it's blue, that means it's not all the way constrained, which means if I grab this, I can wiggle it around, which is cool. It looks like purple means it's projected, and I shouldn't be able to wiggle that around. Yeah, which is cool. That's really nice. So we have this unconstrained thing, which means we can still define some pieces of this. And I'm hoping that I can use, again, this is a slightly different, so maybe I can use this guy. Oh, I just want to measure this, and then I can define what it's going to be. Okay. So, another thing that's different, another thing to figure out. Man, y'all are learning with me today. It's a good time. It's a good time. We don't want any of this. I want to define how this is going to work. Can I right-click on it? Sketch dimension. That's interesting. Oh, is this our guy over here? Yeah, it is. We want our dimension guy, not our measure guy. So basically what this is going to let us do is define some dimensions of our lines and curves. So look, as we click there, it already wants to give us a radius. So we can define this radius as exactly what we said we wanted it to be earlier, 9.1 inches. So you can see it'll bring that in a little bit, give us a nice smooth curve, and really that's still going to be a pretty thick piece. Well, we did say we wanted a 1/4 inch, so maybe we can adjust that. But hey, that's going to be okay. It's going to be a good thick piece. I think we'll be fine. I might try to adjust it after we do this. So after we do that, we've created an arc. Now remember what we said earlier, we want to make this a closed loop so that we can extrude it. So how do we create an arc that's a closed loop? Sorry, I gotta put things up when I'm done with them. So we'll just create a line. We'll just close it off, nice and simple. A straight line from here to here. Bam! You can't see it, but it is there, I promise. So there we go. So we have a line here. There you go. You can see it. We have an arc here. So this is now a closed loop. So we'll go ahead and finish our sketch. There's a nice button there. We'll go ahead and go back to our extrude. And we'll click. So you see it kind of segmented it up since we did have some projection lines there. So we'll click our sections that we want to extrude. I will go ahead and turn it this way so you can see. Now check this out. So this is the cool part. So last time, we took this and we can extrude it and make it solid. This time we want to do something different. We want to go the other way. Now check out what happens if we go the other way. We're actually cutting in to our material here, which is super cool. Now why is it only cutting pieces of it? That is an interesting question. Did we select the wrong corner? Did y'all let me select the wrong corner? Oh, because we're missing a piece. My fault, guys. I was about to blame you guys for everything. There we go. So now we're cutting the entire thing. There's a couple of different options that we can use here. We can either choose our distance. We can pick a different feature that we want to extrude to, or just say, just keep going. I don't care. So that's what I'm going to do. Just keep going. And it'll cut all the way through. So we'll click OK. This should go away. Yep. OK. And there we go. So you can see now we have a cool flat top for our bender eye and a nice curved surface that should fit on our oculus for the bottom. Now say I wanted this a little thinner because I don't need that much material. I can go over here to like the browser area. Well, this is a little different too. So most of the time you can edit the features that you've created. So for instance, if I did this and I wanted to here we go, it's down here. So I can, yeah, so that's pretty neat. So I can edit this extrusion. Come on, let me edit you. So say I didn't want it 1/4 of an inch, say I only wanted it, I don't know, 1/8 of an inch. We can do that, and it looks like it even gives us a live update. Okay, I'm really liking Fusion 360. Well, maybe not a live update. So we'll say okay. And maybe it'll work, maybe it'll not. Yeah, so it looks like it works. So it leaves us with a little bit of material left, and then plenty of material on the sides. That looks pretty dang cool. I don't know what you guys think, but I'm really happy with that. I might actually thicken it up a bit in case we wanted to add some more features. So let me go back here and say 1 point, let's just say 2/10 of an inch. So that's not bad. We can get away with that. Pretty cool. Now there's some other features we can do if we really wanted to. I do because I like just over creating things. So there's a cool little guy called a fillet up here. So what he basically does is make a round edge around any of our sharp edges. So if I want to select that edge and make it a round edge, I can do that. And I can say I want this to be, this one will probably do 1/8 of an inch. That's really big. So that's probably too big. Let's look. Excuse me, hiccups. That's actually pretty cool. So you can see it rounds that edge down, and we can preserves all of our other features. I really like that. So I'm going to keep that. I think that looks pretty good. We're going to keep the top nice and flat. Okay. 1, 2, 5, 1. Yep. So there we go. So, everybody, I do believe that's a pretty decent looking eye. I think I'm going to keep that just how it is. Not change a thing. But I do want to save this. I haven't saved yet. I should probably do that. Whoa, where is... This is too fancy for me, I tell you what. Vendor eye angry. I'm going to name it Angry because I think I want to make these where I can come back and swap them out. So if I want to make him look surprised, I can have a surprised eye or something. I think that might be fun. Project. Oh, okay, so we'll create a new project. Basically, this is just categorizing it. We'll make a Bender Eyes project. How about that? So we can save all of our different Bender Eyes into one project. Okay. Where is this going to save? I don't know. Okay. But it's saved, at least. It's saved somewhere. It's fine by me. Okay, so I want to try out this thing over here. So remember, we're going to 3D print this. So I want to make this into something that I can 3D print. And this is telling me that it's going to do something STL-wise. So STL is the file type we need for a 3D printer. So we'll go ahead and do that. So it wants us to select something, preview a mesh. Okay, well, let's see what we get. We'll select our body here. This might not work for us because it looks like we might have to get another thing here, which is fine. Looks like these won't work. Okay, so that's okay. Let's see if it gives us the option of just saving this and exporting it as an STL. This looks like training. We don't want that, do we? Nah. File. Can we export? Export. We want to export as an STL. Sweet. Requires a cloud transition. Man, these guys, I tell you what. Too much going on. It's okay. So STL is basically the file type that we need to read into our slicer, which is going to allow us to 3D print. Okay, we want to save this to... Typically, every time I save an STL, I'll save it to a specific 3D print location. Don't know if you guys can see this. Kind of hope you can't. You can see all my hidden files in here. Dun dun dun. Just kidding. I don't have anything. Okay. Save. STL. Yep. Okay. So it'll export. What will it do? I think it's sending it to a cloud to be... It's interesting. I've never seen anything like that, but basically sending it off to export, and it'll come back to me. I hope. Well, while that's being done, let's set up our slicer. I will show you what we use for that. Let me grab that guy, and we can bring this into there. So we'll set up a window so you guys can see that as well. We'll call it Cura Capture. So it's looking for... See, you can see the job status there. I didn't know you guys couldn't see that until just now. That's fine. We'll keep it like that. And once Cura pops up, I'll... Well, look at all those mice on the outside of that. I didn't notice that was going on. That's funny. Okay. So I'll do something like that. And then when Cura pops up, I'll adjust it. That's fine. Okay. Yes, Akira does take a long time to start up. I don't know why. But in the meantime, I think we still just have Cooper on. Cooper, are you still here, buddy? Is there any questions you wanted to ask, or anything you wanted to understand about all the engineering work we did today? I will be uploading my Bender eyes to my Thingiverse later on. You should just be able to search me. It's the Face Palmer. It's the same as always. Feel free to search that up. They'll be on there for a free download. You can basically grab them and 3D print them on your own if you have a 3D printer. So you could bring your own Oculus to life. The great thing is about 3D printing is iterative. So if you get it wrong the first time, try again. Who cares? It'll be a good time. 3D printing is also a science, and we'll get into that. And hopefully, my plan was just to have the 3D print stream for you guys. We'll see if we can get it going today. I've been having trouble with the 3D printer. Hasn't been nice. Hasn't been sticking to the bed anymore, which I don't know why. I didn't change a single thing. But we can talk about that here in a second. See if we can get it working for us. Okay, so let's get Kira open going. So this is a really cool program. It's going to look kind of similar to the one we were just using. But what this is basically a program that allows us to tell the printer, let me just do this. It's going to tell the printer what to do. So the printer is not smart. It can't just get a file and figure it out. It has to know what to print, and basically what this is going to do is write a code for us, saying, oh hey, you need to go left, right, up, down, put some stuff here. Yeah, so that's basically what this will be doing. We're still waiting, however, on our STL. Apparently we sent it off to the shop or something. I don't know what it's doing. Very interesting. But let me see where this saved while we're waiting on it. Electronic scripts. So did it even, where would it have saved this? Anyone have any ideas? I'm looking, and it is not. It's not in Fusion 360. The document folder. Is it in just documents? That would be a weird place to throw it. It's very interesting. So maybe we search. Maybe I saved it to 3 objects or something. Maybe, what did I name it? Bender Eye? Angry. I'm just going to search for it. So there's a Q in. Seems like it's done. Maybe it's still copying it over there. Like I said, this is all new to me, so I'm trying to figure out where this program is saving things. I'm just doing a search on my computer so I can figure out where it is. Do y'all hear that wind? That is some loud wind. I don't know if y'all can hear that, but it's like really, really loud. Man, everything is slow. This is why I got a new PC, guys, because it's slow. This one I got in college sometime 5-ish years ago. So in computer age, he's an old man. An old man. One of these days. You can skip ahead if you'd like in this video because I don't know when anything is going to be done. Oh, okay, we got one thing done. We got our STL done. So let's open this guy up. Of course they're updating again. Jeez, man. I feel like I'm updating a new Cura like every week. And how do I turn this one? Okay. So this is Cura. So basically what it does, I've already told you, it's basically telling how the printer to do things. So what we're going to do is go to our new fancy STL that we just made called Bender Angry IV1. Open it up. Bam! There he is! Hey, that looks like exactly what we designed because it is! Because it is! Oh, Zoidberg here! Okay. That's enough Futurama referenced for the day. Just kidding, we're doing the whole thing as Futurama. So, a couple things to think about when you're 3D printing. You're starting at the bed and you're printing up. So any gaps, it's going to be printing on air. So this is not going to work for us because you can't print on nothing. So it'll print nothing, and then just start printing right here. So that's not going to work. So what we'll do is we'll make this a little easier for us to print. So we luckily have a flat surface on the top of our eye. So we are going to select our eyeball. We are going to do our rotate, and we're going to select the surface to align with our build plate. We want it to be this top one. So when I clicked it just now, you can see that it flipped it upside down. Now the flat surface is there, and our curved surface is on top. So that's really nice. And I typically like to center these guys, so for a 0 on there, it won't stay there for long. Okay, cool. So now we have our eyeball. Looks pretty cool. There's one of them, but Bender has 2 eyes, so we want 2. So we're going to take this guy. We're going to duplicate it. I think we have to right-click for that. So we're going to duplicate our models. Where'd you go? Where'd you go? Where'd you go? Multiply selected models. We want 1 copy. So we'll click OK. It'll make a second one for us. Sweet. Pull it down here so we can see it. While we have that selected, we want to, assuming this is mirror, it's not giving us much options. So we want to mirror it this way. Bam, there we go. So you can see now we still have our curved surface that's just mirrored from our other eye. So that's cool. Now another thing you want to think about when you're 3D printing is we want the nozzle, so we basically want our printer to move as little as possible so it saves us time. So to do that, we basically want our parts to be as close together as possible. So how do we do that, you may ask? Well, I'll tell you. Just make it like a puzzle. So we have a flat surface here and a flat surface here. So I'm just going to kind of line those up. So our little nozzle doesn't have to travel this far. So we'll do I guess, I don't know what we didn't really define an angle for this, so it might not be exact, but it'll get us closer. So there we go. So kind of rotate that guy. Let's move him up a bit. I know that there's some hot spots and cold spots on my bed, and I know this is a cold spot, which basically means that the material won't stick. So we'll move that guy backwards. We'll move this guy up. And then we'll kind of move them both. I guess we can't select two at a time. That's fine. Kind of move them both over this way a little bit. Can we get closer? I think we can. Bum, 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 bum. And then we'll want to. I want to rotate this guy a little more. But it's snapping. I want it to snap. So we'll do. There we go. So now look, we can squeeze this guy in just a little bit more. And that'll save us some time, which will be nice. Okay, so there we go. So we have it all laid out. So now we'll look at some of our options here. Actually, heck, what am I doing? To move that all the way over. Make it as even as we can be. If we're gonna go even, might as well go all the way, right? Looks pretty good. Okay. So now some of our options. I won't go through them all. But layer height is basically how thick each layer is going to be as we build up on this guy. Same thing for initial layer height. I kind of want to reset to default on this because I might have been changing some of this. So okay, that's fine. So layer height, initial layered line width. So we're not going to mess with most of this stuff unless we start having print issues and need to come back to it. Our infill is kind of important. It basically says how much material. So we're not printing this as a solid chunk. There's going to be like little pockets and holes in there. So how dense do we want it to be? 20% is fine for this. It's actually probably a little high. Our temperature will come from, seems high too. Temperature will basically come from what material we're using, which we right now have a white in there. And it'll stay the same for all PLAs. So PLA is just the type of plastic. So we'll keep that. That hasn't changed. Support, we don't need support because we have a flat surface we're building on. The speed, travel, cooling is all automated as well. Layer adhesion type. So this is kind of important, especially since we've been having problems. I'm going to keep brim on. You know, I don't want to, though. I'm going to try it with the skirts. I'm going to save 2 of these off because we really don't need a brim. This is a really flat surface. And basically all a brim would do is help us stick to the bed. And with the surface this flat, we don't really need an extra amount of material on the edges here, is basically what that's saying. What skirt will do is just kind of float around the edges just so we can basically get a couple passes of the nozzle. And adaptive layers, we don't really need that either. Because all adaptive layers is doing is just kind of saying, oh, here we need more definition, here we need less. So really this should be good. It's a pretty simple print. So I'll go ahead and click slice. It says it's going to take 2 hours, almost exactly, so that's nice. We can take a look at the preview, which will show our layers if my computer decides to work. Cool, so here are our layers, so kind of nice. You can see, because this is a curve, the layers are kind of difficult for it. So since it's such a shallow curve, but you can kind of drag this up and down and see, hey, for each layer, this is what it's going to look like. Bam. All right, so we will go ahead then and save this off. So let me grab my 3D printers above us. So that's kind of fun. Let me grab, I have well, where would I have put that? Our little card reader. So we have the card, but we don't have the, there he is. That's where he should be. Okay. plug this guy in. And we are going to save to a removable drive. Alright, so it should already be, yep. Cool, so I'm gonna delete that. I'm gonna go ahead and rename this to Angry Bender Eye, what do we call it? Skirt. And then I'm going to go and make another one of these with the brim, just in case we need it. I don't think we'll need it. I really hope we don't need it. We'll slice again, and I can show you all what that looks like. So this is the brim. So you see it's a little bit different than the skirt. Again, we don't need it. We shouldn't need it. So I'm going to hope we don't need this, but we'll have it just in case. Save this to drive as well. I'm going to go ahead and rename this one to Angry Bender Eye Brim. Okay, so there we go. So I have them both saved off. I'm going to click eject so I can grab this, slap it in the 3D printer, and start the 3D print process. And for that, I don't think I'm going to stream that today. Maybe we can talk about that later. I think we've done quite a bit today. I'm working with a few different tools. We've done Fusion 360. We've looked at Cura. We've done some radius math. So we've done quite a bit. So I'm going to set the 3D print up. I'm going to stop this stream, set the 3D print up. If I can get it to work today, I can't promise that it's going to work because I have been having those sticky issues. I'll go ahead and just set the stream up so that you can see it zip-zapping back and forth. So that might be pretty cool. So other than that, guys, thanks for joining me. I'm glad we got to make something cool today. Whether or not I can get the 3D print working today, I will update you with the final product, which should be pretty neat. And obviously I'm going to stick it on the front of my Oculus so it'll look cool. So for anyone that sees this, thank you for joining in, and see you next Wednesday.